Okay, so in this part we're talking about angle pairs formed by transversal. So first of all, what is a transversal? So you have two lines, segment lines, wherever they are, and then a line that intersects them both is called a transversal. So T is a transversal because it intersects two lines. That's all transversal means. And we've got lines L and M. And so here we have, and what we have going on is a bunch of angles here. So we'll mark them 1, 2, 3, 4, 5, 6, 7, and 8. So those are our angles. And I'm going to go back and take off some angles, but you can see there's lots of different angles here. There's 8, and some of them form pairs. So the first ones we're going to talk about are corresponding angles. So let's go with a smaller font size, around 20. Corresponding angles. Now, corresponding angles occur with the angles that are in the same position. So if we look at this picture, 2 and 6 are corresponding angles. So angle 2 and angle 6. With that in mind, what other angles correspond? Well, 2 and 6, you can see how they're both on the same side of T, and then they're both above L or M. So that's why they correspond. So if we look on the other side above, we've got angles 1 and what? 5. So what other angles correspond? Well, 4 and 8, 3 and 7. So there are 4 pairs. So 3 and 7 and 4 and 8. Because they are in the similar position, either above or below, on the left or the right of the transversal, and both above lines L and M, or both below lines L and M. That's all that corresponding angles are. So the next set we want to talk about is alternate interior angles. So same picture, same thing going on, but we will take the picture in a second and make it only have alternate interior angles for a second. So if I was to draw a similar picture with my transversal T, and again L and M, alternate interior, so that means they're on the inside, which is inside L and M. So it's only mark angles on the inside, so that's 3, 4, so 3 and 4, and 5 and 6. Those are the angles on the inside. There's not really enough room to draw them all in there, so I'm not going to. But alternating means to go back and forth across the line. So this angle and this one here alternate. So that would be 3 and 6. And 4 and 5. And those are alternating interior angles. So that's what that means. The next type we'd like to talk about are alternate exterior angles. And that's way too big of a font, so let's take that down to 20. So alternate exterior angles. So alternate exterior angles occur on the outside. So same idea, but instead we're looking on the outside of the picture. So keep drawing the same picture. So I'm not going to draw it again, but there's my picture up here. And the outside angles are angles 1 and 2 and 7 and 8. But we need to alternate or bounce back across T. So the alternate exterior angles would be 1 with 8. So angle 1 and angle 8. And then angle 2 and angle 7. So those are the alternate exterior angles. Then there are the same side interior angles. So the same side interior angles. Now this means we're not going to be bouncing around the line of these. So corresponding angles don't bounce. They are on the left or right of T, but they are in the same position. So they're both above or both below L and M. Same side interior means they have to be on the inside, which means they can only be on the interior of this, but they have to be on the same side. So the same side interior angles are angles 3 and 5 and angle 4 and 6. And those are the same side interior angles. And I'm thinking them, and that's basically it when we look at angle pairs. We also got our vertical angles going on and our linear pairs going on and all of that stuff. So there's a bunch of angles happening here. And these are the angle pairs formed by a transversal.